Hey guys, my voice is not the best today, but I hope you can clearly understand what I'm trying to communicate with you today. All these need to be memorized, whether it's the cotangent, cosecant, secant, tangent, or the other form of the cotangent. These two by now you should have memorized it, just like the cotangent of x is 1 over the tangent of x, cosecant 1 over sine, secant 1 over cosine. And if you multiply the secant by the cosine, you get 1. The sine by the cosecant, you get 1. The tangent by the cotangent, you get 1. Now, if you memorize this, it will facilitate the rest of your understanding. Let's look at the first one. It says, prove the following identities. What I will do is change secant in terms of cosine, change cosecant in terms of sine. So this is the same thing as, I'm making a funny line there. On top, secant is the same thing as 1 over cosine. Cosecant is the same thing as 1 over sine. If you remember our copy change flip rule, it will be 1 over cosine times, of course, x on both of them, times sine of x over 1, which is sine of x over cosine of x, and that's nothing other than the tangent of x. And once I reach this point, I can give myself a check. The same concept here. If you want to figure out what this is, you will say, well, this is 1 over sine divided by 1 over cosine. That's 1 over sine of x, of course, times cosine of x over sine of x. And this is, again, equal, this is over 1. So we have cosine of x over sine of x. And that's exactly the cotangent of x. Once again, once I reach my destination, I give myself a check. Let's go over Pythagorean identities. Using Pythagorean theorem, I will say that r squared is equal to x squared plus y squared. Now, if you look for the sine of theta, I will say sine of theta is equal to y, and cosine of theta is equal to x. Remember, cosine is your x value, sine is your y value. So at this point, I will replace the values here. I will say r squared. Note that this is a unit circle, so r here is equal to 1. So I will say r squared of 1 is equal to x squared, which is cosine squared of theta plus the sine squared of theta. And this is an identity. Usually we write it as follows. Cosine squared theta plus sine squared of theta is equal to 1. Guys, you need to understand something. If you do not memorize this, you are not in good shape. The cosine squared of theta plus the sine squared of theta is equal to 1. I can use again this to go a little further. Let me box this first. If I go a little further, I will say 1 minus the sine squared of theta is equal to cosine squared of theta. Or I can also say 1 minus cosine squared of theta is equal to the sine squared of theta. Let's go ahead and try a few problems. Let's do a few more Pythagorean identities. Another one would be this. If I do, I start with sine squared of x plus cosine squared of x is equal to 1. Let's divide everything by sine squared of x. In other words, I'm dividing this by sine squared of x, this by sine squared of x. and this also by sine squared of x. And you should end up with 1 plus the cotangent square of x is equal to the cosecant square of x. The same thing can be done also if we divide everything by the cosine squared of x instead. So I will start with my identity, which is sine squared of x plus cosine squared of x is equal to 1. And at this point, I will divide instead by cosine squared of x. And I will end up with the tangent squared of x plus 1 is equal to the secant squared of x. Alright, here's the first example. We want to transform sine of x times cotangent of x to cosine. Since I want to transform it into cosine, I will bring the cosine out of the cotangent. So it will be sine of x times cotangent is cosine of x over sine of x. And from here, I can just simplify the sine squared, the sines of x. And my answer is cosine x. The next one says transform sine of x times secant of x, cotangent of x to 1. Since I want to transform it to 1, I will write everything in terms of sine and cosine. So that will be sine. Oh, I can just transform the cotangent first. That might be the easiest thing. By the way, there are multiple ways of proving this. So I will stick to sine of x times secant is actually 1 over cosine of x. Cotangent is cosine of x over sine of x. So if I decide to simplify, sine of x goes away with sine of x, cosine of x goes away with cosine of x, and I'm left with 1. Let's transform cosine squared of x minus sine squared of x to 1 minus 2 sine squared of x. Now, my answer has sine squared of x, but I'm starting with a cosine square. I will transform the cosine square, and I will use what I showed you earlier on the other page, where cosine squared of x alone is 1 minus sine squared of x. And I still subtract another sine squared of x. That will give me 1 minus 2 sine squared of x. This one came from the fact that sine squared of x plus cosine squared of x is equal to 1. So if I move this sine squared of x over here, I get cosine squared is 1 minus sine squared. And the last one is 1 plus, the last one on this page, is 1 plus cosine of a minus times 1 minus cosine of a to sine squared of a. If you distribute this one, you should know that if you have a squared, a plus b, let's do a plus b times a minus b is equal to a squared minus b squared. This is an algebra identity that you're supposed to have memorized already. So this one represents my a plus b, a minus b. So it will be a squared, which is 1 squared, minus b squared, which is cosine squared of a. And remember, 1 minus cosine squared is sine squared of a. Alright, on the last page, I have cosine of m minus secant of m squared to this. So I will go ahead and just use the regular algebra that you know. So cosine of m minus secant of m, and I'm multiplying by another cosine of m minus secant of m. And if you multiply this one, you will have cosine of m. I will show you all the steps here. Minus the secant of m that I'm multiplying by cosine of m minus secant of m. This is just a double distribution, so I will end up with cosine squared of m minus cosine n times secant n is 1. So, but I will write cosine n times secant n minus secant n cosine n plus secant square of n. This is 1. This also is 1. So I have two ones here. So if I want, looking at my answer, I want tangent square and sine square. But I do have cosine square. So I will change this cosine square into 1 minus sine square of m. And I have minus 2 and plus the secant squared of m. All right, if you notice now, my goal is to bring the tangent out. So if I add this one and this one, I will end up with negative sine square of m minus 1, but plus secant square of m. Looking back at the beginning of our notes, I mentioned that I can use the secant. I remember those are the ones that we were dividing, and I say this, I'm putting this in parentheses. This is something that I say. I say tangent squared of x plus 1 is equal to secant square. I'm writing funny here. Tangent squared of x plus 1 is equal to secant square of x. So if I want to find out what the secant is, all I need to do is subtract 1 from both sides. And I will subtract 1 here and subtract 1 here. This will cancel, and I'm left with tangent square is secant square minus 1. So I will use that information here, and all I will have left is this will give me a tangent square. And of course, I still have minus sine square. Instead of x, of course, it's m. And that's where I was trying to reach. Now, let's look at the last one. The last one seems to be one of the easiest ones. First of all, let's find the common denominator. The common denominator here will be sine cosine. So for secant x, I'll multiply it over sine x minus sine x over cosine x. To find the common denominator, I will multiply top and bottom by cosine x here, and top and bottom here by sine x. Now they have the same denominator, but secant times cosine is 1, minus sine times sine is sine square, over sine x cosine x. The 1 minus sine squared of x, you should know it by now, is cosine squared of x over sine x cosine x. What I will do is simplify one of the cosine with this cosine, and I'm left with cosine of x over sine of x, which is cotangent x.